Hello friends, in this lecture we are going to discuss Compton effect, the next point from your elementary quantum mechanics topic. We have finished photoelectric effect, now we will see Compton effect. Both the effect verifies the particle nature, so we have to discuss in detail what is the Compton effect. So the effect was discovered by American physicist H. Compton in 1922. For his work, he received Nobel Prize also for Compton effect in 1927. He demonstrated that particle nature of electromagnetic radiation. One is wave nature, second one is particle nature. So particle nature is proved with the help of Compton effect. So for objective question may be asked, Compton effect verifies the dash dash nature of electromagnetic radiation. So the answer is particle nature. So now Compton found that when a beam of monochromatic X-ray are allowed to fall on lighter elements such as carbon, the scattered X-ray have wavelength larger than the incident radiation. तर कार्बन सारख्या वजनानं हलक्या असलेल्या एलिमेंट वरती जेव्हा एक्सरे फॉल होतात पडतात त्यावेळेस स्कॅटर होणारा जो एक्सरे आहे त्याची जर वेव्हलेंथ तपासली तर ती जास्त असते इन्सिडेंट रेडिएशन पेक्षा, किंवा त्याला विरुद्ध लिहिता येईल त्याची एनर्जी ही कमी असते than the incident X-ray after scattering from the surface of object is known as Compton effect. So larger wavelength or less energy, that is decrease in energy. So in this way we can explain the Compton effect. In diagram it is more clear. You can see here. So this is the incident X-ray which is falling on this element carbon. So when it falls on the surface of carbon, so this one is scattered X-ray which is falls and then gets scattered, and this is the changed position of electron, so that is moving electron. Now when we observe this lambda dash or wavelength of this scattered X-ray, so we have larger wavelength than the incident one, or decrease in energy occurs in the scattered X-ray than the incident X-ray. So this is nothing but an effect. So according to classical theory, which is the previous theory than the quantum one, so when electromagnetic radiation strike on any object, no wavelength change should take place. तर क्लासिकल थेअरीनुसार जेव्हा इलेक्ट्रोमॅग्नेटिक रेडिएशन कोणत्याही ऑब्जेक्टवरती पडतात त्यावेळेस जे काही स्कॅटर्ड होणारा लाईट आहे किंवा रेडिएशन आहे त्याच्यामध्ये कोणत्याही प्रकारामध्ये वेव्हलेंथमध्ये बदल होत नाही असं कोण सांगतं? क्लासिकल थेअरी. म्हणजे क्लासिकल थेअरी फेल होण्यामागची कारणं या ठिकाणी तुम्हाला दिसतील. The incoming electromagnetic wave causes the electron to oscillate with the same frequency as the wave. म्हणजे जी वेव्हची फ्रिक्वेन्सी आहे त्याच फ्रिक्वेन्सीनं इलेक्ट्रॉनला ऑसिलेशन प्रोव्हाइड केले जातात इलेक्ट्रोमॅग्नेटिक रेडिएशन कडून. Therefore the oscillating electron should re-emit the electromagnetic wave with the same frequency. म्हणजे या ठिकाणी दोन पॉइंट आपल्या लक्षात येतील. वेव्हलेंथ मध्ये सुद्धा कोणताही बदल होत नाही आणि फ्रिक्वेन्सी मध्ये सुद्धा कोणताही बदल होत नाही, हे अकॉर्डिंग टू क्लासिकल थेअरी. पण प्रॅक्टिकल मध्ये कॉम्प्टननं प्रूव्ह करून दाखवलं की आपल्याला वेव्हलेंथ मध्ये पण बदल होतो आणि फ्रिक्वेन्सी मध्ये पण बदल होतो, त्यामुळे ही क्लासिकल थेअरी फेल ठरते. So Compton experiment proves the failure of classical mechanics and confirm the quantum theory. So Compton explained the scattering phenomena according to quantum mechanics by considering the particle nature of radiation. So when an incident photon strikes the electron at rest, the photon transfers its kinetic energy and momentum to the electron. Same principle as like the photoelectric effect one. Here photon is transferring its kinetic energy and momentum to the electron. Now the scattered photon will have lower energy कारण त्यानं त्याची स्वतःची kinetic energy momentum हा इलेक्ट्रॉनला दिल्यामुळं जेव्हा तो बाहेर पडतो किंवा स्कॅटर होतो त्यावेळेस त्या फोटॉनच्या एनर्जी मध्ये डिक्रीमेंट झालेली दिसून येते. Thus the wavelength of scattered photon increases. Always keep in mind that E is equal to h nu, frequency and energy having directly proportional relationship and wavelength and energy having inversely proportional relationship. So this shift in wavelength is given by delta lambda is equal to lambda dash minus lambda. Bigger one is lambda dash, that is wavelength of scattered radiation is always greater, minus wavelength of incident radiation, that is equal to h upon me into c in bracket 1 minus cos phi, and this shift is nothing but delta lambda is known as Compton shift. यामध्ये c जे असेल ती वेलोसिटी ऑफ लाईट असेल आणि हा जो फाय आहे दॅट इज द अँगल बिटवीन इन्सिडंट अँड स्कॅटर्ड फोटॉन जो आपण अगोदरच्या डायग्राम मध्ये बघितला, and me is the mass of electron, h is the Planck's constant. So in this way we can explain Compton effect. Now hc, that is equal to h upon me into c, which is known as Compton wavelength lambda. That is Compton wavelength of particle is always equal to wavelength of a photon whose energy is same as the mass of the particle. तर एनर्जी आणि मास हे जर दोन सेम असतील तर त्याच्या बरोबरीने असते कॉम्प्टनची वेव्हलेंथ. सो इन दिस वे वी कॅन एक्सप्लेन द Compton effect. The remaining part we will see in